Hello everyone, I am Emmanuel Omatuku. I'll be talking about my research, which is about the modeling of sea ice formation using the phase field method. Sea ice is an important component of the global climate system. As a result, predictive climate models have to incorporate its processes into their algorithm. However, these models fail to account for the internal processes of sea ice, in particular sea ice formation. These processes are very important because they affect the bulk, they influence the bulk properties of sea ice, which in turn affects the global climate system. Even at the small scale, we haven't achieved a realistic three-dimensional model of sea ice formation. So it is against this backdrop that this research intends to address that gap by developing a three-dimensional model of sea ice formation. To model sea ice formation, we need to split it into smaller processes. When the atmosphere temperature goes below the freezing point of seawater, there's a formation of crystals which essentially become ice. So we have a phase transition from seawater liquid to sea ice solid. With seawater containing salt, at temperature below -8 degrees, you get a precipitation of salt. We have solid salt forming, but the salt and the ice are incompatible due to their chemical composition, so they reject each other. But now, because the freezing interface is moving faster than the salt can escape, you get salt getting stuck inside the ice, so we have those brown pockets. Also, because the freezing interface is not planar, it has kink in it, it's anisotropic. There's a crystal reorientation when it forms. As you end up having brown channels, brown pocket forming, and due to hydrodynamics, you've got seawater going in and out, pressure buildup in those pockets and channels. So we have these processes essentially end up giving us a sea ice structure which is like a sponge. And this is the one we need to model. When it comes to modeling, we're using the phase field method and the mathematical software SGen and SFEM. As I speak, we've already implemented the phase transition and the phase separation, and we're busy developing and about to implement the anisotropic growth model. This is the current state of the research. Thank you.